All right, in this video, we're going to be working a quiz on inverse functions. We're going to start off with writing a formula that gives x in terms of y. So we're just going to solve for x. So I think this is a little small. Let me zoom in a little bit. I guess I just didn't give you all enough space to work. But we can subtract 9 from both sides and have 1/2 x squared. If I'm trying to get x on its own, I'm going to need to get rid of that 1/2. So I could multiply both sides by 2 to get rid of that 1/2, and I'd have 2 times y minus 9, that's 2y minus 18, equals x squared. And I could access x by taking the square root of both sides. Remember, if you take the square root of both sides of an equation, you end up with plus minus, so I have x equals plus minus the square root of 2y minus 18. If f of x equals 2 to the x plus 1, what is f inverse of 16? Alright, so what I told y'all is whenever you see f inverse of a number, what you're going to do is immediately set f of x equals that number. So we're going to be looking for f of x equals 16. And we've got a formula for f of x. That's 2 to the x plus 1. But if you think about it, now we know what power of 2 16 is. Okay, if we didn't, we would use a log with base 2. We'd take the log base 2 of both sides and we'd kind of proceed from there. But we know what power of 2 16 is. 16 is 2 to the 4. So we say 2 to the x plus 1 is equal to 2 to the 4, which means that x plus 1 has to equal 4, meaning x is 3. So in conclusion, we say f inverse of 16 is the x value that corresponds to y equals 16. That's equal to 3. If we're given a pair of functions and asked to determine if they're inverses, we're going to use composition of functions. Okay, that's the definition of inverse functions, is that I need to be able to take f of g of x and g of f of x and have them both come back just x. If either one of them were to not come back x, then I would know they weren't inverses. So f of g of x, wherever I see x in the formula for f, I'm going to replace it with g of x. So I'm going to have g of x squared plus 5, and that would be the square root of x minus 5 squared plus 5. And okay, that's not just going to be, x minus 25. Okay? I forgot to have, the quiz graders check to see if people were, doing that. But I think I would have given you credit if you said that was not equal to x just from there. So it'd be kind of tough to penalize people for doing more algebra and just doing it wrong. But if we were to square this, I think I'm going to show you what would happen. Okay, right? That would be square root of x minus 5 times square root x minus 5. I would first 2 square root x times square root x, that's just x. Outside 2, it's minus 5 square root x. Inside is another minus 5 square root x. And the last 2 is plus 25. So you can see on the constants even, the 25 plus 5, that's 30. And I need just x. So I'm going to say that this is just not equal to x. And so I'm going to say no, they are not inverses. No, and my justification is like all the work I did right up to that. I did composition of functions, it didn't come back just x, so no, they're not inverses. If we're given a graph, okay, h of 0, this is when I was trying to give you to be nice. Okay, we go to x equals 0, we look at the height of the graph, that's y equals 1, so h of 0 equals 1. And the value of h inverse of 4, if I see h inverse of 4, I'm going to set h of x equals 4, and I'm going to find x. And this isn't really like a solving situation. This is we go, okay, h of x, that represents the y-coordinate. Y equals 4 is right there. I go over find graph, trace back to the x that got me there. That's going to be x equals 3. So I can conclude that h inverse of 4 is equal to 3. All right, with this one, f of x, find f inverse of 1. Okay, so kind of like the last one, I'm going to just say, okay, f of x needs to equal 1. I've got a formula for f of x, so that's 2x minus 2 over 5x plus 7 equaling 1. I'm going to multiply both sides by 5x plus 7, or you could look at it as, the only way a fraction can equal 1 is if the numerator and denominator are equal. Either way, I'd get 2x minus 2 needs to equal 5x plus 7, because 1 times 5x plus 7 will just be 5x plus 7. And then I'm going to solve for x by maybe subtracting 2x from both sides. And then maybe subtracting 7 from both sides, and dividing by 3, and I can see that x is going to equal negative 3, so f inverse of 1 equals negative 3. All right, now if they ask us to find g inverse of x, we need to just solve y equals log base 2 of x minus 3 for x, and then we're going to replace y with x. Okay, so we're going to say, all right, start with y equals log base 2 of x minus 3. And we need to know how to get rid of a log to access that x on the inside, where we need to take 2 to both sides power. So I'm going to say 2 to the y equals 2 to the log base 2 of x minus 3. Well, those kind of kill each other off, and I'd have x minus 3. And I can solve for x by saying x equals 3 plus 2 to the y. And this is a suitable rule for the inverse, but this is not g inverse of x. It will say, really this is a formula for g inverse of y. So g inverse of a number is equal to 3 plus 2 to that number. If we needed to, plug in x for g inverse of x, well, that's what we'd have. 3 plus 2 to the x. Okay, so f inverse of 4, we're going to find f of x equaling 4. We're going to go look in this column. There's where f of x equals 4. We backtrack to the x that got us there. That's x equals 2. So I can conclude f inverse of 4 is equal to 2. All right, form B. Asked to write a formula that gives x in terms of y. We're just going to solve for x. We're going to start by adding 8 to both sides. And then probably getting rid of that 1/2 by multiplying both sides by 2. So I'd have 2y plus 16 equals x cubed. And then I could get at x by taking the cube root of both sides. So I could say x equals the cubed root of 2y plus 16. Remember, when you take the cube root of both sides of an equation, you don't need that plus minus because the cube root's unique. If f of x equals 3 to the x plus 1, what's f inverse of 27? Okay? If we see f inverse of a number, we're going to take that and we're going to say f of x equals that number. So f of x equals 27. We have a formula for f of x, that's 3 to the x plus 1, that needs to equal 27. But we don't need to take a log of both sides. We know what 27 is in terms of 3. It's 3 to the third. So I'm going to say, this is 3 cubed. And so I know that x plus 1 power, that needs to equal 3. That means that x plus 1 needs to equal 3, and I would say x equals 2. And so I will say that f inverse of 27 is the x that corresponds to y equals 27 on the graph of f. That's x equals 2. All right, with this one, if we're going to determine if two functions are inverses, we have to do composition of functions. We need to do f of g of x and g of f of x, and they need to both come back just x. So think about f of g of x, and that's going to be g of x squared plus 4. And this would be square root of x plus 4 squared plus 4. And if I square the whole square root, I'm just going to get a thing on the inside, the radicand. So that's x plus 4 plus another 4. That's going to be equal to x plus 8, and that is not just x. Okay, so I'm going to conclude that f and g are not inverses. Okay, if we've got a graph and we want the value of h of 3, we go to x equals 3, we look up and find the graph. That's going to be y equals 4. H of 3 is equal to 4. H inverse of 0, that's going to be the solution to h of x equals 0. Here and say, all right, h of x needs to equal 0. And so I can say, all right, where y equals 0, that's right here. So I go over, I find some graph right there that corresponds to x equals negative 2. So I'm going to say that h inverse of 0 is equal to negative 2. Number 6 is find f inverse of 1. So we're going to take f of x and we're going to set it equal to 1, kind of like we've been doing the whole time here. Formula for f of x, that's 4x plus 7 over 8x minus 5 that equals 1. I'm going to multiply both sides by 8x minus 5. And then I'm going to solve for x. Maybe I'll add 5 to both sides. subtract 4x, divide by 4, and I'll get x equals 3. So f inverse of 1, that's going to equal 3. And okay, if we want to find g inverse of x, we're going to kind of start with y equals g of x, 2 to the x minus 3. And we're going to solve for x. And then we're going to need to plug in x at the end on our formula for the inverse, but I'll talk about that when we get there. So if we want to get the variable down out of the exponent, we're going to need to use a log. And I'm going to use a log base 2 because that's the base of the exponential, so I'm going to take log base 2 of y. And that'll equal log base 2 of 2 to the x minus 3. That would be x minus 3. And then I'll solve this equation by adding 3 to both sides. So 3 plus log base 2 of y. And then that's a formula for x, so that's a formula for the inverse. So meaning g inverse of y in this case is 3 plus log base 2 of y. If I wanted to plug in g inverse of x, I could do it like that and have a formula for g inverse of x. All right, last one, find the value of g inverse of 4. That's where g of x equals 4. I go to the column for g of x. I find where it equals 4. I backtrack to the x that got me there. That's going to be 5. Not sure what's going on there. But g inverse of 4 is going to equal 5, and that's all for this quiz. So thanks for watching.